Hello guys, so our exam prep has started. So let's begin with find the LCM and HCF of 18, 27 and 81. Easy question, easy marks, right? So we are going to find the LCM and the HCF by using prime numbers. So let's begin with 18. So this is 18. We are going to find the prime factors of 18. So we then say the smallest prime number divisible into 18, that is 2. 18 divided by 2 will give us 9. The smallest prime number divisible into 9, that is 3. 9 divided by 3, the answer is 3. The smallest prime number divisible into 3, that is 3. 3 divided by 3, the answer is 1. So 2, 3, and 3, they are the factors of 18, but to be more specific, they are the prime factors of 18. So what's coming next is I'm now going to write 18 as a product of its prime factors, meaning I'm going to write 18 as 18 equals to 2 multiplied by 3 multiplied by 3. So what I'm doing here is I'm writing 18 as a product of its prime factors, because when I say 3 multiplied by 3, the answer is 9. 9 multiplied by 2, the answer is 18. So when I multiply my prime factors, the product is 18. Therefore, when writing like this, I have written 18 as a product of its prime factors. Okay, so we're done with 18. Let's continue to 27. So remember, we are trying to find the LCM and the HCF of 18, 27, and 81. So let's go to 27. So 27, so what's going to happen right now is we are going to factorize 27. We have factorized 18 via using prime numbers, and therefore the factors are what we call the prime factors. We are going to do the same with 27. We are going to factorize 27, but we are going to factorize 27 by using its prime numbers, because the factors we're looking for are just not any factors. We're looking for the prime factors of 27. So we then are going to say the smallest prime number divisible into 27, that is 3. 27 divided by 3, the answer is 9. The smallest prime number divisible into 9, that is 3. 9 divided by 3, the answer is 3. The smallest prime number divisible into 3, the answer is 3. 3 divided by 3, the answer is 1. So we have factorized 27. To be more specific, we have prime factorized 27. So these are the factors of 27, but the prime factors of 27. So what's coming next is we are now going to write 27 as a product of its prime factors, meaning if I multiply the prime factors, if I say 3 multiplied by 3 multiplied by 3, the product will be 27. So let's test 3 multiplied by 3, that is 9. 9 multiplied by 3, the answer is 27. So we have written 27 as a product of its prime factors, because remember, these are the prime factors. So when I multiply the prime factors, the product is 27. So now let's do the same thing with 81. Let's do the same thing with 81. Okay, so 81, so what's going to happen now is we are going to factorize 81, but we are going to factorize it using prime numbers. So we're then going to say the smallest prime number divisible into 81, the answer is 3. 81 divided by 3, the answer is 27. The smallest prime number divisible into 27, the answer is 3. 27 divided by 3, the answer is 9. The smallest prime number divisible into 9, the answer is 3. 9 divided by 3, the answer is 3. The smallest prime number divisible into 3, the answer is 3. 3 divided by 3, the answer is 1. So we have factorized 81 into its prime factors. So what's coming next is we now have to write 81 as a product of its prime factors, meaning if we multiply the prime factors, if we say 3 multiply by 3, multiply by 3, multiply by 3, the product is 81. So what we have done here is we have written 81 as a product of its prime factors. Okay, so this is all very important. So when the question says find the LCM and the HCF, you've got to show all these steps. Do not write answers only. I repeat, do not write answers only. You will lose marks. Show all these steps. Okay guys, so now let's find the HCF. I prefer to begin with the HCF. So let's find the HCF. So when finding the HCF, what we focus on is the common factors, right? So the HCF is derived from the common factors. What are common factors? Common factors are those factors that appear here, and also appear here. Let's look at 2, for instance. 2 is not a common factor. Yes, it appears here, but then it doesn't appear here, it doesn't appear here. So 2 is not a common factor. A common factor, we have to find it here, and find it here as well. So let's see. So now 2, we have already established that 2 is not a common factor. So let's jump over to 3. So we can see that we have 3, we have 3, we have 3. So 3 appears on all 3 levels. So 3 is a common factor because we can find 3 here, we can find it here, we can find it here. Okay, so in this case, 3 is a common factor. Remember that common factors don't have to form a straight line, right? Somebody can say, let me use a different color pen. Somebody can say there's 3 here, or you can see. Let me use a pencil. Somebody can say there's a 3 here, there's a 3 here, there's also a 3 here. So even though the 3s they have identified do not make a straight line, yet we will refer to them as common factors because there's a 3 on this level, 3 on this level, another 3 on this level. So what we're looking for 3s on each level, whether they take on a straight line or you find them haphazardly, does not matter as long as there are 3s on each level. Okay. So back to my red pen. So we have identified that there's a 3 here, there's a 3 here, there's a 3 here. So because this 3 is common on all levels, right? This 3 is common on all levels. We then say that it is a common factor. What these levels have in common is the fact that there's 3, there's 3, there's 3. So 3 is a common factor. So we are going to take 3 out as a common factor. Multiply by, so let's look for another common factor. So let's jump over to this 3. Okay, we can see that we can find 3 on this level, another 3 on this level, another 3 on this level, right? So remember, they do not necessarily have to take the form of a straight line. Even if you find them like this, it's okay, as long as you find 3 on all 3 levels, okay? So in this case, again, there's a 3 here, there's a 3 here, there's a 3 here, so 3 is a common factor for this level because it appears on all levels. So This 3 is a common factor. We can find it here, we can find it there, we can find it there. So this 3 is a common factor. So what's going to happen now is I'm going to take out this 3 as a common factor. Let's see if we've got other common factors. So there's 3 here, there's 3 here, there's no any other 3. There's 3 here, I don't have, there's 3 here, right, on this level, there's that 3, there's no any other 3, so that means that the only common factors I have are 3 and 3, are these. So we have taken out 3 as a common factor and taken out 3 as a common factor. And we then say 3 multiplied by 3, that is 9. So the HCF is 9. So now let's find the LCM. Let's find the LCM. So we are going to find the LCM. I'll just do the LCM here. So this is the formula I like to use for finding the LCM. I always say that the LCM will be the HCF multiplied by the uncommon factors. Multiplied by the uncommon factors. So the HCF is 9, right? That means that where there is HCF, we are going to substitute with 9, multiply by the uncommon factors. So we are going to go back to our work here and try to see if we can find uncommon factors. So we know that 2 is an uncommon factor because there's no 2 on this level, there's no 2 on this level. We've got only 1, 2 on one level. So 2 is an uncommon factor. It is not common. If it was common, it will be found everywhere on each level. Meaning if it was common, we'll find it on this level and on this level. So we're only finding it on this level. So 2 is uncommon, right? We only find 2 in 18. There's no 2 in 27. There's no 2 in 81. So 2 is uncommon. So we're going to take out 2 as an uncommon factor. And let's look at this 3. Okay, so there is 3 in 27. There is 3 in 81, but then there's no any other 3 in 18. Okay, so we've got 3 in 81, we've got 3 in 27, but there's no any other 3 in 18. So it means that these 2 3s are uncommon factors, but then we're not going to write them as 3 and 3. We're just going to take out 1 3 as an uncommon factor and then go back here, multiply by 3. Okay, so what else? So we still have this 3 left alone. There's 3 in 81. We don't have any other 3 in 27. We do not have any other 3 in 18. So this 3 is an uncommon factor. So we're just going to write it here as an uncommon factor. And then we're going to say 9 multiplied by 2 multiplied by 3 multiplied by 3. The answer is 162. So our LCM is 162. Our HCF is 9. So therefore, our LCM is 162. Therefore, our HCF is 9. Okay. Sorry for the poor bit quality, guys, but this is what we have. Let's work with it.